This problem tasks me to find the area and the perimeter of this composite figure made up of a triangle with a half circle cut out of it. So I'm going to start by looking at this as a triangle first. Area of a triangle is half base times height. Because I have a right angle here, I can treat either of these sides as my base or my height. So I'm going to take this and I'm going to rotate it. When I rotate this figure up, effectively that's what I have. So that triangle is not so hard to find the area of. 1/2, base of 18, height of 26. I can go ahead and I can calculate that out. I'm going to end up with an area of 234 square feet. Now there's this cutout. There are a couple of things I want to think about. First, do I have the radius or the diameter? Second, it's a half circle. So I'm going to have to be taking whatever I get for an area and cutting that in half. So let's talk about the area of a circle first. That's going to be pi r squared. This distance provided is the diameter. So I need half of that. 4.5 squared. Because half of 9 is 4.5. That's going to give me an area equal to 63.62. But that's a whole circle. I only want half of that. So I'm going to cut that into two parts. So the area that's been cut out, that area right there, that's a half circle. So it's half of this circle, which is going to put me, and just to be sure, I'm feeling a little shaky today, 31.81. That's what's been cut out. Now I can go ahead and I can finish the area by subtracting this from this. I take my 234, which is my total area, subtract 31.81. I get 202.19 square feet. That will represent the total area of this triangle. The second half of this problem calls on us to find the circumference, or the perimeter, of this whole figure. So I need to figure out what the length of these pieces are going to be all the way around it. Now the good news is I've already got two of them. The third is going to take a bit more work. So for example, I need that length along there. What I'm going to do is I'm going to apply the Pythagorean theorem to get this hypotenuse. I've got A up here, I've got B up here. Now I can go ahead and I can get C across there. So 18 squared plus 26 squared is going to equal C squared. In that case, C is that distance along there. 18 squared and 26. Again, the answer of C is roughly equal to 31.62. Now, that's the distance all the way along that bottom. You notice I've cut out 9 units to represent this gap. So I'll subtract 9 from that. And that puts me at 22.62. So this length here plus this length here is 22.62 units. What I still need to get is that piece along there. Now, to do that, I'm looking at that again as a half circle. The circumference of a circle is 2 times pi times the radius. Radius, we said, was 4.5. So 2 pi times 4.5 is going to give me 9 pi. Or, if I turn that into a decimal, 28.27. But that would be a whole circle. I only need half of that. So I divide that by 2. So I take that, if I divide that by 2, because I only want a half circle, I get 14.14. So I've got that piece along there. That's going to be 26 units, 26 feet. So that's that part. 18 comes down that side. Going across the bottom and not including the cutout, I've got my 22.62. That's in terms of feet. And then lastly, the part that's been cut out is 14.14. If I add those all up, so 14.14 plus 22.62 plus 18 plus 26, my final answer is 80.76. That would be the full perimeter of this composite figure, the distance all the way around the shape, simply by finding all the sides I can find and adding them up.